Today discussing high-level physics para about the circular motion. Circular motion is the most important for the physics and mathematics also. Combined mathematics also part 2 paper having circular motion. After the physics, no go deep, but circular motion about theories, more theory intend with the combined mathematics. Today we are discussing the circular motion. What is the circular motion? What's similar circular motion? Circular motion. Right? Now, day-to-day life, we can see everywhere circular motion. Some car taking the train. This is also circular motion. Car taking the train. This is also circular motion. Into this part. Merry-go-round. Merry-go-round also having circular motion. Yeah. Some planets. Planets are rotate. Planets are in the orbit in the circular motion. Planet. Circular motion. Another thing is the bicycle wheel. Bicycle wheel rotating and traveling. That is also circular motion. Circular motion everywhere we can see. Circular motion we are considering having other parametric of the motion. Normal parameter of the motion is the displacement, time, and velocity, or speed. Or speed. These are the four things. Here also have these things discussed in here, but different. Circularly all are taken. Circularly all are taken. Now here we consider the circle. Circle, radius R. Radius R circle. Radius R circle. One position here, P1 is the one mass. In considering mass, P1 is stay here, place 1 here. And after time t, this is the t equals 0, initial time. After t time, simple t time taken to P2 position, t equal t. T equal t. This angle we say, this angle, this one. Theta angle displacement. Theta angle will be displacement. Actually, linearly displacement is the P1 to P2. This path along the path linearly. Along the path linearly we say S. 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 Angularly theta. Angular displacement theta. Right? Angular displacement theta. Angular linear displacement S. Theta is the angular displacement. Angular displacement. Displacement. SP is the linear displacement. Placement. Linear displacement. Right? Anyway, linear angular taking the time pass actually t time pass to P1 to P2. Time taken P1 to P2. Simple t time in seconds. Here we can say meters. Here theta radian. Theta is the radian. Radian. You may remember, you must know this thing. 2 pi radian is equal, or 2 pi radian. Pi radian is equal 180 degrees, 180 degrees. Pi radian equal 180 degrees. This formula using, we can all the time convert to degree to radian, no? Radian to degrees. Anyway, we can convert, we can do. Right. Now you know that this is this one, speed, we say speed. This is normally going constant, constant velocity, constant velocity. And you really go, and you will travel constant velocity, angularly travel constant velocity. And another case have not in constant, not in constant. That is not constant. It will vary the time to time. Second part we are discussing later. Here, velocity is all the time tangentially, tangentially. V here, V here, V here, V here. Right? Velocity V, velocity V. We know that linear equation, velocity equal velocity equal displacement over time. Linear velocity we consider here. Linear velocity displacement over time. Velocity V equal S over T. S over T. Travel distance over time T. Travel distance over time T V. Fine. In trigonometry, this formula has. This is the length S. This is the subtend angle theta. R is the radius. All the time S equal R theta. S equal R theta. S equal of that R theta. Here, both taking, we can say V equal R theta over T. R theta over T. What is the theta over T? Theta over T angularly displacement per unit time. Angular displacement per unit time. Rate of change of the angular displacement. Rate of change of the angular displacement. This is special notation. Theta over T, all the time we are using omega. V equal omega R omega. R omega. Clearly we can see omega R. Now here, omega is telling angular velocity. Angular velocity. Angular velocity also constant here. In this case, angular velocity is constant. We are normally denoted representing like this omega. Omega. Is travel omega angular velocity in the circle. Angular velocity omega in the circle. We have formulas for that. Theta over T omega. Omega equal theta over T. Theta is equal omega T. Omega T. One equation. And the second equation is V equal omega R. V equal omega R. V equal omega R. This is the linear motion and angular motion connect each other formula. V equal omega r. This is the angular displacement all the time equal angular velocity into time. Angular velocity into time. Angular velocity into time. Right? Now we can say this thing. T equal omega t, V equal omega r. V equal omega r. Right? You see the board and try to understand what I say. I given about 5 minutes to see the board and understanding what I say. Right. Now see the board and understand. You must know omega unit all the time, radian per second. Okay, omega unit, radian per second. Omega unit, radian per second. Omega unit, radian per second. Radian per second. We you know that meter per second. Meter per second. Right? Either what means all the things have a understanding. If you repeat and repeat again, you can understand it very well. Right? Understand it very well. This is a starting program for the physics level, physics and combined mathematics. All things covered by the section by section in the short videos. Right? All are the short videos. So convenient, you can easy to see and put the comments also. Right, okay. Now we see the centripetal force. What is the centripetal force? Actually, centripetal force is the one of the force acting towards the center. Acting towards the center. Acting towards the center. Acting towards the center. Now here say the circle move in the body. Omega angular velocity. Omega angular velocity. What that? Omega angular velocity. Omega angular velocity. Right? V is the linear velocity. This is tangentially acting. V and omega is constant all the time. Constant. In this case, we are considering on the constant case. That constant. R is the radius of the circle. This is moving here, constant velocity or constant angular velocity. There's no, what is not have? No change the velocities. There's no acceleration. Here to here, there's no acceleration. Right? But here, we say the mass M, mass M, M mass here. After time taken, T mass M, and mass moving in the circle. Right? Mass M, 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 ma the center. Right. Actually, acting some force here towards to the center all the time, like this, m omega squared r. This is the force. This force saying centripetal force. Centripetal force. In this case, also this question also acting here, m omega squared r. If this comes to this question, m, this also acting here, m omega squared r. This is called the centripetal force. Centripetal force. Most of cases, some are telling the centrifugal force. Actually, real term of the centripetal force. Centripetal force. Actually, centripetal force giving say F equal m omega squared r. You compare with the F equal ma, famous equation. F equal ma, Newton motion equation. M equal ma. A is the acceleration. In this case, this is acceleration a omega squared r. A equal, this one is considered a equal omega squared r. And the angular acceleration actually, angular acceleration omega squared r. M into acceleration is the force, Newton, here, Newton force. Angular acceleration to the here moving to the circle body, omega squared r. Omega is the angular velocity, omega squared r. But it will travel in the constant velocity. In this case, tangentially no have the, what is no have? Tangentially no have the acceleration. Tangentially no have the acceleration. In this case, then they have angular acceleration, not angular acceleration. Sorry, acceleration omega squared r towards to the center. Towards to the center. Omega squared r with the centripetal acceleration. M omega squared r. M is the mass in kilogram. Omega radian per second. R is the meter. M square is the force. Okay, force. This is in Newton. This is the centripetal force. The centripetal force. Right? Today I am discussing to up to here only. Later, second video I am continuing with the circle motion in part 2. This is a part 1 of the circular motion. Thank you for listening to me. Now we see next video.